I bet you some of you are saying, SOS me, someone help me. This is unhealthy. Why are you making this so hard, Mr. Jameson? I feel your pain, but we gotta keep moving on. So, we discussed that if we have three angles, congruent angles, it doesn't work. But if we have three congruent sides, three matching sides that are congruent, it does work. This lesson, we're going to be looking at the combinations. So we're going to be looking at these 6 combinations to see which ones prove that triangles are congruent and which ones do not give us a sufficient amount of information. So here we go. All right, the first one that we're going to look at is AAS. Let's try AAS. So remember, the purple slides are Mr. Erlin's slides, who graciously gave them to me to use for this video for this year of 2015, November of 2015. And so let's try AAS, or 2 angles followed by a side. So that means that side is not in between these 2 angles. So here is our standard triangle, and we have an angle, and then a side that is not in between, these 2 angles, okay? So we bring the angle over, and we first start off with a congruent angle. So far, so good. But is there a way to make an angle that is not congruent? Well, it turns out no matter where we put this other angle, we can never line up the angles and the sides. We can never line up the angles and the sides. So this is the only place where the angles and the sides will line up. So yes, AAS is enough information to prove congruence. So we can say yes to AAS. So angle, side, congruence theorem. So this is where you're going to write it down. If 2 angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So here we have, where's my pen? There we go. We have an angle, and a side. An angle, and a side. So these 2 angles are congruent, these 2 angles are congruent, these 2 sides are congruent. So therefore we know that the triangles are congruent. So here, describe the corresponding parts and the justifications for using them to prove the triangle is congruent by angle, side. So in this situation, it's given that BD is an angle bisector to ADC. It's also given that these angles are congruent. Angle A is congruent to angle C. So it is given that angle A is congruent to angle C. It's also given that BD is an angle bisector of angle ADC. It's also, so therefore, angle ADB is congruent to angle BDC. Angle BDC by definition of angle bisector. And then we can say, so this is by reflexive property of congruence. What can we use here for the reflexive property of congruence? We can say that BD is congruent to itself. BD. Therefore, triangle ABD is congruent to triangle CBD by angle, side. Since these 2 angles are congruent and this side is congruent to itself, we have angle, side. So voila, we know these 2 triangles are congruent. Okay? Now back to visualizing another angle pair. Let's try angle, side, angle, or 2 angles and an enclosed side. So we have an angle, a side, and an angle. So now this time, the side is in between the two angles. So we can make a congruent triangle. So here is our congruent triangle. But can we make another one? Can we make a triangle that's not congruent to it? Nope, we can't, because these angles are kind of locked in place by this segment. So no matter how we try to move, no matter how we try to move these angles, we'll always have a congruent triangle. So yes, ASA is enough information to prove triangles congruent. So now, not only do we know that AAS works, but we also know that ASA works. So if angle, angle, side works, and angle, side, angle works. Now let's try side, angle, angle. So we have a side and then two angles. Side, angle, angle, or side, angle, angle. Doesn't this look pretty similar to angle, angle, side? Well, because it is. It's the exact same thing as angle, angle, side. And so, yes, it works, because no matter what we do, that angle, if we move that angle, we'll still have the same thing. So what we do instead is that instead of getting angle, angle, side and side, angle, angle confused, we basically start whichever letter is highest in alphabetical order. So we'll just use angle, angle, side. So yes, side, angle, angle is enough information to prove congruence. It's really the same thing as angle, angle, side. But I'm going to gray it out because since it's the same thing, we're just going to use angle, angle, side instead of side, angle, angle. So now we know that these two are true, and this one is true as well, but these two are the same, so we're just going to use these two. So angle, angle, side, and angle, side, angle. So now it seems like if we know that there's two angles and one side, no matter what, we know that the triangles are going to be congruent. But let's take a look if we know one angle and two sides. Are none of these, all of these, or some of these going to be congruent? So let's look at ASA. Wait, sorry. So before we do that, let's take a deeper look at ASA. So so we know that they're congruent, but let's do some proofs with them. So to use ASA congruency postulate, the congruent side must be between the two congruent angles. So ASA, because that's why the S is in between the two A's, because the side needs to be in between the two angles, or the two A's. Okay, so determine whether you can use ASA to prove triangles congruent. So we're going to try to prove that KLM is congruent to triangle NPQ. So we could use third angles theorem to prove that angle M is congruent to angle Q, but angle, 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 remember, is not enough information to prove these triangles are congruent. We need to find another way. So, but we have a congruent angle, then congruent sides, and then congruent angles. So, yes, you can use ASA because the congruent side is between the congruent angles in both triangles. Now let's take a look at this one. Triangle EFG, is it congruent to triangle XYZ? So here we have congruent angles, and congruent sides. While this side length is between the two angles, this side length is not. So no, we can't use ASA because one of the side lengths aren't between the angles. Okay. So now that we've looked at all of the relationships with two angles and a side, now we're going to look at all the relationships with two sides and an angle to see which ones of these are congruent. So we have side angle. Oh, so we have a side, an angle, and a side. A side, an angle, and a side. So if we bring it over here, yes, we can create a congruent angle. I mean, a congruent triangle. But is there another way to move these sides and angles around to create a different triangle? And there isn't. So SAS is enough information to prove the triangles are congruent. These triangles are congruent. So with SAS, woohoo! All right, we have a lot of trios that work. But let's take a look at ASS and SSA. Note that these are going to be the same thing. ASS and SSA are going to be the same thing. So that either both are going to work or they're both not going to work. So I put these out of order, but let's do SAS first. If two sides and the included angles of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So we have angle K is the included angle, angle N is the included angle, and so therefore these angles are going to be congruent. So to use SAS congruence postulate, the congruent angles must be between the two congruent sides. So for SAS, the angle needs to be in between the two sides. For ASA, the side needs to be in between the two congruent angles. Okay, so let's take a look at SAS. Use SAS to explain why triangle WXY is congruent to triangle WZY. Well, it's given that ZW is congruent to XW. It's also given that angle ZWY is congruent to angle XWY. And then segment WY is congruent to segment WY by reflexive property of congruence. So therefore triangle WXY is congruent to triangle WZY by by side angle side. So since we know that that's congruent, by side angle side, we know that these triangles are congruent. So here, what we can do is that we can solve for these angles to see if they are congruent. Well, 36 times 3 plus 5 is 113. And then 9 plus 8 is 17. And 3 times 7 is 21. So we have corresponding sides that are congruent, and an included corresponding angle. Therefore, we can say that triangle PQR is congruent to triangle VWX by side angle side. So the last one that we haven't tried yet was ASS and SAA. And we're going to call it by ASS because A comes first in the alphabet. So we have an angle, a side, and a side. Okay, angle, side, side. We bring them over. Yes, we can create a congruent triangle, but is there another triangle that can be created? Well, what can happen is that this line can be swooped down to here to create this line. And now we have the same angle, the same side and another of the same side lengths, but it creates a different triangle. So therefore, their ASS does not prove triangles are congruent. There are no ASSs allowed in class, okay? So we can mark that as red. So here is a summary of all of the shortcuts for proving triangles congruent. Angle, angle, angle doesn't work. Angle, side, side doesn't work. But the rest of them do. Angle, angle, side, angle, side, angle, side, angle, side, and side, side, side. However, there is one last thing. There is a special type of ASS that does work. There's a special type of ASS that does work, and it's called hypotenuse leg. So if you know that, and so this is only works for right triangles. If the hypotenuse and a leg of a triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So the hypotenuse of a triangle is the side length across from the right angle. So we have an hypotenuse and a leg that are congruent. Therefore, we know that the triangle is congruent. So let's take a look at number 6. Determine whether you can use hypotenuse leg congruence theorem to prove the triangle is congruent. So first you have to ask yourself, so we're trying to prove that triangle UVW is congruent to triangle WXU. Are UVW and WXU right triangles? Well, yes, they are. Yes. Is the hypotenuse of UVW congruent to the hypotenuse of WXU? Yes, they are. They are congruent because they're congruent tick marks. Is a leg of triangle UVW congruent to a leg of triangle WXU? Well, yes, indeed, they are. The leg of UW is used in both triangles, and so we can use the reflexive property of equality to say that. So therefore, we can prove these triangles are congruent by hypotenuse leg. So lastly, let's try this one. Can we prove HL with this one? Well, no, we can't. We know that this is a right angle, and we know that these legs of the triangle, of the right triangle, are congruent, but we do not know if the hypotheses are hypotenuses are congruent. So since we don't know that the hypotenuses are congruent, we cannot say that these triangles are congruent. We would need more information. So in summary, these are the valid triangle congruents: AAS, ASA, SAS, and SSS. Hopefully, through doing the exploration activity in 5.3 in the 5.3 application, watching these videos, doing some practices, that this will become easier to remember, that these three work. We won't use SAA as it is the same as AAS. Then the ones that do not work because there are not enough information are AAA and ASS, except for HL. So it's basically an ASS with a right triangle. That's HL. We're not going to use SSA because it's the same thing as ASS. All right, that is it. Go on. I wish you the best on the online quiz, and I will see you guys on Thursday.